Hello students, we'll be doing the remaining portion of hydrogen chloride today. We'll be discussing the method of preparation of hydrochloric acid by dissolving the gas in water, and there is a special arrangement and mechanism by which the back suction is avoided. Then reaction with ammonia, then acid properties of its solution, reaction with metal oxide, hydroxide, carbonate, and then precipitation reaction with silver nitrate solution and lead nitrate solution. First we'll go for the chemical properties of the hydrogen chloride gas. First is combustibility. It is neither combustible nor supports combustion. It doesn't burn, extinguishes the burning splint. If it is heated at about 500 degrees Celsius, hydrogen chloride dissociates into hydrogen gas and chlorine gas. If hydrogen chloride gas reacts with metals like sodium, calcium, magnesium, zinc and iron, it gives metal chlorides as well as the hydrogen gas. Now generally these metals should come before hydrogen in the electrochemical series, and those will be giving the corresponding metallic chloride and hydrogen. Now reaction with ammonia. Hydrogen chloride reacts with ammonia to form dense fumes of ammonium chloride, that is NH4Cl. Now here NH3 is the gas, HCl is the gas, whereas NH4Cl is the solid. So this is an example of two gases forming to give solid. Now formation of hydrochloric acid. Hydrogen chloride gas is dissolved in water. HCl acid, that is hydrochloric acid, is formed. Both are polar covalent compound, that is hydrogen chloride gas as well as hydrochloric acid, all are polar covalent compound. HCl, that is hydrogen chloride or hydrochloric acid, ionizes in water forming hydronium ion, that is H3O plus, and chloride ion, Cl minus. Now you should note that dry hydrogen chloride gas and liquefied hydrogen chloride do not turn blue litmus red. So it shows the non-acidic character of the dry gas. Very important point. Liquefied HCl also doesn't conduct electricity. It shows the covalent nature of HCl. Now it dissolves in toluene also, but it does not turn blue litmus red and does not show its conductive nature. So this confirms that absence of hydronium ions in toluene. Now there is a laboratory method for preparation of hydrochloric acid. The aqueous solution of hydrogen chloride gas is known as hydrochloric acid. This is prepared by dissolving hydrogen chloride gas in water. The gas is passed into water until no more gas is absorbed. The product is concentrated and contains about 36% hydrogen chloride by mass in the whole solution. What is the procedure? Say an inverted funnel. So an inverted funnel connected to the hydrogen chloride gas supply is placed in a beaker in such a way that it touches the water taken in the trough. So this you can say trough or beaker. Here the water content is taken. Now this is remaining portion is your hydrogen chloride gas formation setup. From this gas, this is directly connected to this water or supplied to this water. So since hydrogen chloride gas is highly soluble in water, the water rises up in the funnel. So water rises up in the funnel. The back suction occurs, and in turn the level outside the funnel falls, creating an air gap between the rim of the funnel and the surface of the water. This is the rim of the funnel and the surface of the water. So the pressure outside and inside then becomes equal, and water which had risen in the funnel falls down again. So this process continues till the water in the trough is saturated with hydrogen chloride gas and resulting in the formation of hydrochloric acid. So you can see this one very carefully. The rim of the funnel is in the contact with the water surface. This is the rim. So as the water level rises, it raises the funnel. It raises the funnel by giving the back suction. Now the rim of the funnel loses contact with the water surface. Now the rim of the funnel is losing the contact with the water surface. So air from outside rushes in. So air from outside had rushed in. and equalizes the pressure. This is the inverted funnel arrangement for the preparation of hydrochloric acid, and very important part in view of examination also. Now, mechanism by which this back suction is avoided. First is funnel arrangement. This funnel arrangement prevents or minimizes the back suction of water, provides a large surface area for absorption of hydrogen chloride gas. Now, why this funnel arrangement is used? Hydrogen chloride gas is sufficiently soluble in water, so it is absorbed in water more quickly than it is being generated in the flask. Here the whole setup is shown over here. If you have to show hydrogen chloride gas formation, then you have to show up to this, and you have to add it with a gas jar. And if you have to show the hydrochloric acid formation, then you have to do this setup. So, in this case, the pressure in the delivery tube and the flask is reduced, and the atmospheric pressure from outside forces the water back up to the delivery tube. So, which is called the back suction. If the tube is made of ordinary narrow glass tube, the water will quickly fill it and pass over into the generating flask, which will stop the reaction and result into the explosion due to the heat produced when water comes in contact with hot concentrated sulfuric acid. Where is that? It is here in this flask. So it will be going directly to the flask if you are making ordinary narrow glass test tube. So there is a funnel arrangement is given to increase the surface area over here. So precaution to be taken. To prevent such accident, an empty flask, that is anti-suction device, is put between the generative flask and the water trough. Empty flask is provided between the generative flask, that is this is the generative flask, and this water trough in which you are dissolving the gas. In this case, the back suction occurs, the water will collect in it and will not reach the generative flask. If there is any back suction of water, water will be going here. It will not go to the generative flask. A dilute aqueous solution of hydrochloric acid gets gradually concentrated on distillation till the concentration of the acid reaches 22% HCl by weight and 77.8% water by weight, which boils at 110 degrees Celsius. No further increase in concentration is possible on boiling, as molecules of HCl gas get mixed with water vapor. Now there is a constant boiling mixture, or azeotrope is a solution, this is prepared, which boils without any change in its composition. So similarly, hydrochloric acid forms constant boiling mixture at 110 degrees Celsius. Now go to the physical properties. Color is colorless, pungent choking smell. Then acidic test. Concentrated acid is corrosive and causes blisters in the skin, readily soluble in water in all proportion, and boiling point is 110 degrees Celsius. Come to different chemical properties. First is the nature. It is strongly acidic, shows all properties of acid. These are the in action on the indicator, and when react with the metal, it gives the metallic chloride as well as hydrogen. With oxides and hydroxides, again this gives off metallic chloride as well as water. With salts of weaker acids, these are the salts of weaker acid. What is the acid over here? Here the acid is carbonic acid, here also carbonic acid, here also carbonic acid, here also carbonic acid. So base plus acid give the salt. So these are the salts of weaker acid. Decomposes, gives off carbon dioxide, corresponding chloride salt and water. Similar for sulfide, you will get sulfur dioxide gas, corresponding chloride and water. Then you go for metallic sulfide with hydrochloric acid, gives off metallic chloride and hydrogen sulfide. So dilute hydrochloric acid reacts with thiosulfates to produce sulfur dioxide gas. How to see that? Dilute hydrochloric acid reacts with thiosulfates to produce SO2 gas, as well as yellow colored precipitate of sulfur is there. Then reaction with nitrates. Dilute hydrochloric acid does not normally react with nitrate, but with lead nitrate and mercurous nitrate, it reacts with HCl to produce white PPT of lead and mercury chloride. So red chloride and mercurous chloride both are white in color. With silver nitrate, dilute HCl reacts with the silver nitrate to form thick curdy white precipitate of silver chloride. Now, which is insoluble in nitric acid but soluble in ammonium hydroxide solution, forming diamine silver chloride salt. When dilute nitric acid is added to the clear solution of diamine silver chloride salt, a white PPT of silver chloride is formed. Here it is shown over there, and white PPT of HCl when exposed to sunlight, it gives silver and chloride. Now AgNO3 silver nitrate is used as a test for hydrochloric acid and also for chloride ion. On warming with metallic nitrides, dilute hydrochloric acid gives metallic chloride and oxides of nitrogen. So here the reactions is shown. You get both the oxides of nitrogen are formed. Then oxidation of hydrochloric acid. If hydrochloric acid is reacted with any oxidizing agent, we get the metallic chloride, chlorine gas is evolved and water is formed. Now this is called aqua regia, a mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid is called aqua regia. So you get nitrosyl chloride, nascent chlorine as well as water. This nascent chlorine reacts with the noble metal like gold and platinum to give the soluble chlorides. Last is test for hydrogen chloride gas and hydrochloric acid. Hydrogen chloride gas possesses a characteristic irritating smell. HCl gives thick white fumes of ammonium chloride when glass rod dipped in ammonia solution is held near the vapor of the acid. With silver nitrate solution, both acid and the gas gives the white precipitate of silver chloride. This PPT is insoluble in nitric acid and soluble in ammonium hydroxide. A greenish yellow gas, chlorine, is liberated when concentrated HCl is heated with manganese dioxide, and this chlorine gas turns starch iodide paper bluish black. Thank you for patience hearing. Thank you.